Hello everyone, let's wait for 1-2 minutes until everyone joins us. Okay, let's start. Hello everyone again, I hope you can hear me well. So, let's start today's session. Yes, we'll start today's session with one comment about the activity extra 05, where you had to this one. So that to complete the activity you had, or you'll still need, if you are planning to do it, you need to add the dependency in POM file as it's requested, and after that, this one you can find it on ODOV. One moment. Find it here under extra exercise. Yeah, you can check some additional materials for extra exercises under the section of extra exercises in ODOV. Here for JSON, you can follow these instructions. Some hints mentioned here in this okay. Okay. Okay, that's Okay, you're still not able to hear me, right? Okay, are you able to hear me now or not? 1 2 1 2. Okay. Okay, are you able to hear me now? Okay, thank you. Yeah, thank you. Sorry for this issue. Just it works a bit differently every time, but okay. So yeah, as maybe you noticed from the yeah. So I hope you should be able to see my screen. Yeah, as you probably noticed, for the activity x205, you need to add the dependency in the BOM file, which is the core file of the project, right? So yeah, if you have the project, it should be at the bottom of the folder with the project files. Then here you need to add the dependency, and as it is written in Nodova, you can check it under the section of extra activities. So I have all the sections here. You can go to extra activities, and for each extra activity you can find for extra 4 we have different, but I most likely will also cover XML topic. Then you'll also be able to do the original file XML cars from activity x204, but not now, a bit later. But yeah, for activity x205 you have to work with JSON parser, and here you also can find some information about JSON. Here just basic information from Wikipedia that you can read, but maybe tomorrow we will, or not tomorrow, maybe next week we'll have some additional session about JSON maybe. But yeah, here you can find what is the dependency you need to add to POM file. After that, once it is done, you need to ask for the project itself. When maybe as you remember, when we had to import the project. So after we imported the project, we had to load the dependencies, to download the dependencies from using Maven. And here we just basically do the same. We copy this command, we go to our project, to the folder of our project. Just in my case, it's workspace with this project name. You can also use the command line. So here you can also just, so if you have Git installed, you can just right click here and press on Git bash here. After that you'll have the console where you can just write the command maven eclipse, which will load all the necessary dependencies using Maven. It is likely that most likely you have, and some of you sent it to me that you got this error. It's not a problem in our case. Actually, yeah, the main thing is that what we need to have is to download the dependency, the GAR file, which should be located in M2 folder repository, which in my case it's under my user M2 repository. And again, go to repositories. Here you'll see all the dependencies loaded for the project. Then under the org, you should be able to see the JSON folder here. In case you still just maybe 205, just maybe let me create a new file here. No, not new file, new class. Just test JSON. So for example, if we want to import JSON from here. In my case, I'm able to see it. In your case, maybe initially you won't be able to access it using the import. How you can just yeah. So first of all, please check if you have the file here, right? As I said, you should be able to see this file, and here you find two GR files. So just what you need to do, in case this doesn't work, you can right click again on the project, then go to Java build path, and you have the libraries here, and in my case I just can add external GAR file, and you can basically add it from here. So again, right click on the project, Java build path, libraries, and class path, and add external GARs. Then you will see I already added it, but you can add it and use it here. So after that, this one will be solved, and you should be able to work with JSON classes. Right? I hope this one is clear for those who had the issues with JSON. So let's move on. Yeah, last time I promised that we will also check how debugger works. Maybe a small presentation. So last time we implemented the class getPracticalNumbers, just for example to check how it works. In our case, we can create again the main void just to check to run it. And yeah, for example, from here we can create the object. Okay, I see the question from Ilza. Yeah, Ilza saying that she has only one GAR file, not two. Don't worry, just yeah, just select. So yeah, that's what Ilza has. So yeah, just select this one. Okay, about JSON. Basically this is the file you need to use, this GR. That's the answer for ILSAM. Okay, let's move on. From here we can for example call the method get practical numbers. So it's maybe from 10 to 30. Yeah, maybe we just need to, let's just check, maybe again to 30 just, or to 20. So don't have a huge range of them. Yeah, basically we don't need to return anything because we just want to do it for test purpose. Right, then we can put the breakpoint. Yeah, for every debugging, just to start doing something, you need to put the breakpoint. So it means this is the place where the program will stop yeah, it will stop just to, so you can do the debugging, right? And then after that you can run the program, run it as debug as, and yeah, basically the same way you execute. After that the debugger will run. Yeah, in our case, basically what you need to have, you need to display this window, this view of variables. You will need it, and yeah, in case you don't have it here, I just like to have it here. You can have it maybe in somewhere different place, but it's not quite important. You can just you can also, yeah, you can go to window again, show view, other, and here you have the wall section for the debugging. There are some different things here. You can also, yeah, but yeah, in general you need to have the view of variables, because this is basically the core of the debugging, that you can see the variables inside, which are used inside the program, and what are the values of the variables. So you just open it here. You can also select some other modules. It's not really needed for us. Yeah, let's just stick with variables, and here you have the controls, the main controls of debugging. The most simple step into, which means that you will, so if this is the method call, maybe not this case, but yeah, well, let's see it. So here we don't really have, yeah, we have one method here. Let's maybe put the breakpoint here. Another breakpoint, you can put as much breakpoints as you want. So every time you put them, just not every time, but for every breakpoint, the program will stop once you press resume. So for example, in this case, so we are here at the moment. If we press resume, it will go to the next breakpoint, right? And once you press the resume again, since we don't have any breakpoints to stop, the debugger will be terminated. Right, then let's maybe start again, just to have another check. Yeah, as you remember, as you already maybe noticed, that we go from here. So this is the main method again. It's executed as Java application. Then we call the method get practical numbers, and we go here. Yeah, maybe let's skip this again, just to show you one thing. Maybe let's remove this breakpoint. You can yeah, you can double press toggle breakpoint for the second time, so you have the breakpoint. So yeah, first of all, you don't have the breakpoint, then you put the breakpoint, then you just call the same use the same command, toggle breakpoint. It will remove the breakpoint, right? Okay, well, we don't need it here. Let's, for example, move it from to here, and let's put it here as well. Yeah, maybe let's put it one line. Yeah, for the first one. Again, we can go to the debugger, and yeah, now here, and here you have the main controls. You can step into, which means that we go inside the method call. So in this case, we have the constructor, but yeah, we have the constructor, which we don't have constructor defined in this case, but it thinks that we should go inside the constructor. Maybe let's just to show you, maybe let's define the constructor here, just a simple one. Yeah, for example, we have dummy variable here. Yeah, it's just one small thing. Just dummy variable. Then let's define the constructor. Let's define the constructor, then let's just do some stuff here. This dummy equals dummy again. Then let's call debugger again. So now we're here as well. Okay, since this is the start of the program, we are here. Then we can go into, which means that we go inside the constructor. And so yeah, here's the constructor is called. It means that it calls this logic. Then we again go to the next step. It calls the constructor from yeah, as you can see here, it calls the constructor from the superclass, which is object class in this case, right? Because again, every class is inherited from the class object. Then it calls the constructor of object class. It is initial. Then it goes to the next line, which is here. And so yeah, since this is the just simple statement, it calls it and finishes the call of constructor, and we move on. We move on. Here also we go inside. So this is the smallest step you can with F5 or this button step into. This is the smallest step you can do in the debugger. Right. I hope it's clear about it. Then we have step over, which just means that we go to the next line. So right, just the same, but it's not the smallest step. We just go to the next line. Moment. I need to. So yeah. And F6 just goes to the next line. But in case, yeah, maybe let's just finish the debugging. In case you have, for example, here we have the breakpoint, which is located inside the constructor method, yeah, constructor logic. Then we start the debugging as well, and even if we go to step over, it goes to the next breakpoint anyway. So it is not possible to go through the breakpoints using F6. You'll stop at the next breakpoint anyway, despite the fact that you just call to step over. Okay, yeah, but just simple idea that you need to, not need to, but you will go to the next line. Then there is a command F7, which means step return, just in case you are located inside the method. Maybe let's remove this breakpoint. If you are inside the method, like in this case, if you press F7, you will go out of this method, just here. So the method is called, it will run the program until it goes outside the method. Right, yeah, these are the main commands. We'll skip this one, but yeah, just for the debugging, it's enough to have these commands, and you will, of course, you can explore it a bit deeper. Maybe we'll have a separate session about it. But yeah, just for simple debugging, you can go through the logic using this commands, and here you can see the variables. Basically, here you'll be able to see all the variables here. Just maybe let's finish the debugging and start it again. We don't need these breakpoints. Yeah. So yeah, and here you can see the values of the variables at current point. So you can also see this. So this is the object we are currently located in. You can see the global variables of this object. Since this is the string, yeah, again you can see that the string is not a primitive data type. It has some information inside. We'll not export this, but yeah, again, just remember that string is the object as well, so it has some parameters under it. But yes, here you can see the value for the global attribute, and yeah, for this case, that's practically it. What we have from the perspective of global attributes, and all of the attributes can be checked here at the current point of the debugging. Then some other variables are defined here. You can, not in this case, but yeah, here you can see how the variables are. And yeah, here you can see that we defined the array. So the array is initialized. It has all the elements. Once you press on it, you can see all the elements of the array. You can also see them this way. Right, then let's use 6. Yeah, just maybe the most yeah, from my experience, the most used command is step over F6. And just in case you want to, of course, if you want to do some deeper check, you can do F5. And if you're sure that you have nothing to explore inside the method, you can usually use F7 and F8 until the next breakpoint again. Right, then here you can explore every step. Yeah, since here we can use F6. Then you can see that the sum is defined here. Also the value of the iterators is here as well. And the values of all other variables are here as well. Then you can just go through every step, and yeah, once the value is changed, it shows the yellow. It highlights it in yellow, and yeah, yeah, that's practically it. You can export it like by do every step and check if there's a problem somewhere or not. Right, then in the same way you can also debug the unit tests. Right, so in this case, if you press right click on the unit test file and press J unit test, yeah, maybe, yeah, sorry, I just missed press the wrong button. Yeah, and yeah, once you run the unit test, it will also run the debugger. But yeah, for unit tests, just it may be a bit complicated because yeah, for example, in this case, it has the timeout, and it can be problematic to test it carefully. So maybe we need to kind of have some small stops, because the unit tests again are defined in the way that they check for the speed again. So you have to have a good implementation speed, like in this case, and that's why it has the timer, and you won't be able to debug for a long time. You want to have some small stops. It is most likely that you'll be able to do it with the unit tests as well. Right? Any questions about the debugger? This is just a small introduction in case you want to use it. Yeah, it's very great. It's a very great thing to do when you do the coding. So you're welcome to do it. Okay, let's move on then with the abstraction, with the session, with the things we start doing last time on Wednesday. So as you remember, we discussed the abstract classes, and again the idea is that it's just the same way of classes with some exceptions. Basically, there are two main exceptions there. The first one is that you cannot instantiate the class, the abstract class. So you can't create the object with the reference to the abstract class. And yeah, and the second option, the second property of the abstract class, main property, is that it can have the abstract methods. So it means these are the methods without the implementation, and the abstract classes are used as the superclasses. They act in absolutely the same way as all the simple classes do, with the exception that again they cannot be used as the reference type for the objects, but they are used as the superclasses of just they can be used as the superclasses of other abstract classes. So in this case, you will need to go down to do the implementation as well, and they can be used again for just simple classes where you need to implement all the abstract methods of the abstract class, right? Then let's maybe have a small small example. We have an abstraction. So in our case, we'll create the class test bank. So, yeah. You can, if you want to create the class as the file, as the separate file, you can click on the abstract here, or just define it. Just define it here. Yeah, if you want. Then yeah, so this is just a simple class. Let's create the abstract class. Abstract class bank. So then we can define the abstract integer. For the abstract classes, you just need to abstract methods. You just need to define the access modifier. In this case, it's default. So yeah, for the abstract methods, there is again one exception, that you cannot define the private abstract methods, because it doesn't. Again, as I said last time, it doesn't make sense, because all the methods need to be implemented in the subclasses, but you cannot implement the private methods. So in this case, you can have again the default one, the protected one, because you can implement it in the subclasses, and the public one with the same reason. Let's maybe just use the default one, and yeah, then let's have the class, for example, SBI, which extends our abstract class bank, and it shows us that we need to implement the abstract method. And let's just do it. In this case, it just works, as I said, as the overridden method. So here we just can, for example, return kind of value, integer value. Then we can have another abstract class, for example, BNB, which also extends the bank. Sure. Yeah, we need to override. Let's just use it this way. Just do it this way, then I have to kind of other value. And here we can define the object, just bank. Yeah, as you can see, you can, the same way as for the simple classes, you can declare them as the types, but you cannot, as I said, you cannot instantiate them, because this is the abstract class. You cannot create the instance of the abstract class. Then, but you can create the instance of any subclass of this class which is not the abstract class. Okay, just simple here, system out print just rate of interest is just can add the percent here. yeah, for one. And then the same way you can do it for another class. Yeah, in this case you do the upcasting. You cast a subclass to the superclass, and yeah, you just run it, and you'll see that we have the results from two different banks. Yeah, just that's how the abstract classes can be used. Also, you can, let's maybe have one example with the constructor. Yeah, let's test abstraction. Let's have, so let's imagine that we have the abstract class bike. And yeah, let's have, you can create the constructor as well as for any other class. Again, despite the fact that we cannot actually instantiate the class, we can do the construction of this class. And yeah, here just let's print that we are inside the constructor. And we can have again the abstract voids. Run in this case. Change gear, for example. Yeah, excuse me, outside the constructor, I'm just missed. Yeah. Sorry. Yeah, of course you need to have it outside the constructor. Just imagine you have the gear. Just let's imagine we have kind of class gear. Just don't use the it as a type. The gear. Gear. Simple change. Yeah, for example. Yeah. String state parked, for example. Yeah. If you run, yeah, just let's use it this way. Alright, then we can extend this class. For example, Honda Spike. You need to implement the void run. This state equals, for example, is running. Yeah, just as an example. Here again you need to create the object. Just run. And of course you can call change gear. Just create the gear here. So as an example, and then we shows that the bike is created, and yeah, the idea is that we can have the constructor inside the abstract class, which is just same constructor as for all other classes. All right, that's pretty it about the abstract classes. And yeah, again, just a small overview. The main idea for abstract classes is just to have maybe not the interface, but the class which can be used as the base for other classes, but it actually cannot be used as the object. As the object, and you are sure that it will be extended without the independent usage of it. And yeah, another option is that, as I said last time, you can have the all the methods and attributes static. In this case, there is no reason to have a simple class like we do it in our case. So if you have all the methods, all the attributes static, you don't need the object. You can use the abstract classes and define the static attributes, static objects there. Right. And that's pretty it about the abstract classes. So do you have any questions? No, if not, then let's have the break now, and we'll talk about the interfaces after the break. Okay, let's move on with the interfaces. Um, let's start the presentation. Another option to achieve the abstraction are the interfaces. So as you remember, there was sorry for such switching, but as you remember, there was a slide which just a moment. Where it was written that the abstract classes can achieve the abstraction from 0 to 100%. I hope you now understand how it is achieved or not in abstract classes, and on the other side for the interface it will always be 100%. And let's move on and let's discuss why and how can we use it. As it said, interface is a shared boundary between two separate components of a computer system exchanging information. It's like a contract between user classes and used class, which implements used interface. Java interface is an abstract class which lists declaration of methods and variables without actual implementation. So basically, it means that the interface is just kind of the same class as the abstract class, with the exception that interfaces have all the methods, which all the methods are abstracted. Right, then interface is the mechanism Java to achieve abstraction again. There can be only abstract methods in Java interface, not method body. And interfaces are used to achieve abstraction and multiple inheritance in Java. That's maybe the main difference, and not the main, but the most important difference between the abstract classes and interface, that we can achieve um, maybe not the multiple inheritance, but kind of multiple inheritance when we have multiple classes. In this case, not the classes, but interfaces, which can be implemented inside the class. So the idea is that, again, used to achieve the abstraction. I think there are too much mentions about it, but that's the most important mention. And by interface we can support the functionality. That's just small key points here, and it can be used to achieve lowest coupling, as I said. But let's just have a small introduction here. So interfaces can be created the same way as we can create the class. So the package. Maybe let's talk more about just a class, num and interface. So maybe in our case, let's just create the class to display all the information. Test interfaces. So here we can create the interface. Let's just maybe start with some more or less practical examples. So we have now we have the interface. Let's call it. Let me search for a bit for the example which makes sense at least a bit. So yes, just in our case, what would be want it to be, for example, printable. Yeah, for example, let's have kind of printable interface which implements, not implements, but defines the method. Like in this case, we have the method print for printable. Then, yeah, actually the same way as for the abstract classes, we can implement it, but not using the extends keyword, but the keyword implements. And here we can define them, not define, but pass the name of the interface to be implemented here. And here, of course, it asks us the same way as for the abstract classes. It asks us to implement the interface. So let's do it. Here we can implement the interface. Yeah, the same way as for the abstract classes, with one difference. With again the most important difference that we can create another interface here. Just maybe let's have showable example, and here we have the method show, and using comma we can implement another interface. And as I said, we need to showable, yeah, sorry, show. We need to implement the method from other interface as well. And this is why it is called multiple inheritance, because we have multiple interfaces to be implemented inside the class. And you can deal with them in kind of the same way as for the abstract classes. Like if we talk about the variable definition, like in this case, we can define them as the date type for the instance. Again, you need to, of course, you can leave it as is without the initialization, but of course, I think it makes sense that we cannot okay, yeah, we can. That's maybe also a bit. That's not the point we'll discuss now. But yeah, in general, you cannot call the constructor the same way as we do it for the simple classes, because this is the interface. And as you remember, for abstract classes, we cannot instantiate them. Absolutely the same can be applied to the interfaces. So it makes sense, but we can do the upcasting, like in this case, the subclass of the interface is here. So the upcasting is allowed, and now we can, and here we can use only the methods defined in the class, not in class and interface. In this case, it's printable. Right, print. So yeah, it makes sense that the interfaces can be used in different classes. Like in this case, class A implements printable. Right, it can also be used here. Obviously, you need to override it here, and Yeah, just too many times we use it. Just as you see. So yeah, the idea is that the interface can be implemented in different classes, and of course it can have the different implementation inside different classes. Yes, that's the yeah the introduction for the interfaces. And yes, one more thing. I think we'll have it. Later here as well. So maybe let's not discuss now, but let's move on, and then we'll meet some interesting things here as well. So yes, there are some properties. Interface can be declared by only public access modifier. So you cannot have the private interface. I'm not sure if in this case, yeah, you cannot declare it as private one because it's illegal for them. Just by default, they're all public and they can be used as the public ones, right? Then Java interface lists method declaration, signature without actual implementation. That's what I said. Interface variables are implicitly public static final, because you cannot don't have the class to implement them, so that's why they are declared as public static final. Maybe not again, not this one. And yeah, as you can see, it is declared as the constant. So we need to showing. And yeah, I'm sorry, yeah, for string. String, yeah, by default, variables here are defined as the public final and yeah, and static. Okay, let's move on. One interface can be implemented by several classes. That's what I've just shown, and classes can be inherently unrelated. So yeah, the idea is maybe let's just some schema. So yeah, imagine we have interface A, just interface A. Then we have one class A, that's CA, let's imagine that's CA. Then we have another class CB. Some of them will have the subclasses. Yeah, A1, A2 for example, it doesn't really matter. Here as well, there are some subclasses. And of course some of them can have the interface here, but technically these classes, technically this hierarchy is not related to this hierarchy, but both of them can implement the interface. So they can be not related with each other, right? Let's move on. Again, one class can implement several interfaces. That's the idea. How the multiple inheritance can be achieved here, and general syntax as well. So we have the public interface, then we have the name, and of course it can extend the superclasses. That's the simple example. We have the interface with the methods defined. We have the flyer. Flyer can take off, can land, can fly. Then of course we have the class airplane, which implements this interface, and there are some implementations for, not some, but there are the implementations for the methods defined in the interface. And that's the example of the interface. So the hierarchy, how can interfaces be used? So yeah, that's maybe a bit tricky, but again we have the interface flyer, which can be implemented in the classes like airplane, bird, and Superman, for example. And these classes can have different superclasses. Like in this case, Superman is the subclass of Homo sapiens, which is the subclass of animal. Then there's a bird, which is directly defined as the subclass of animal. Then there's an airplane, which is just defined again as the subclass of the vehicle. And as you can see, there are no relations between the vehicle and Homo sapiens, or the vehicle and animal. And yeah, again, vehicle and flyer. So the hierarchy can be mixed here. Then again, we can have the so-called virtual methods for the interfaces. And yeah, as said, by default, methods declared in interface are actually virtual methods, because their behavior can be implemented differently in different classes. So maybe let's have an example. We have the interface. We have the interface. Just let's have the, for example, computer. Just power on, for example. And that's the void. And let's have the class which implements this. For example, MacBook. Class computer. Here we need. Let's have again string state. So by default off. Here we can on, for example, in this case. And yeah, maybe let's maybe create another class. let's create another class, be surface, and let's imagine it's located somewhere here. Then it can also implement the interface, which yeah, we can see it here. Then we need to but maybe let's, for example, overcomplicate it a bit. Let's use the class state here. Sample, then and private. Yeah, private. What's private? Yeah, again, let's use state. No, just let's string state. Once again, let's use the default of private void set state, string state, for example, and the state equals equals state. For example, or yeah, maybe let's add kind of additional check. This equals state, then print out that point that the state cannot be changed. And else, just set it up here. And yeah, not private void, but public void, yeah, just for setter. Public string get state. You just can return this state. Right, yeah, as you can see, we'll have the different implementation here. Let's, for example, have private state. And yeah, here we have different implementation. Because yeah, as you remember, there we just had the attribute which is the string in that class. Here we just have the more complicated data type, so which is state, which has some logic inside, and yeah, let's change the state here. Set state. Yeah, so we have different implementation here, and here we have and again, what we do, we define the variable. So in our case, again, we can type it as the computer. Let's just use the, but yeah, again, we cannot use the interface as the type of the reference. So we need to create the instance of the fully defined class, right? and from maybe, and if in this case call the method power on, so it will turn to power on. But if we go to if we want to go to the implementation, imagine you don't see the in this case you can see the implementation of, and you know that the implementation of the class MacBook is here, and you can see that if we call something from the variable computer, it will call the implementation from class MacBook. Here it makes sense, but if you imagine if you have kind of more hidden logic, like for example class, here's maybe let's use abstract class. So just be kind of utility class, for example. Imagine we have the static public static void, not void, but the method which will return as get computer, for example, which will return as the instance of the computer. It's already just maybe let's kind of use a test. So, and here we can just write something, return, for example, new Surface Pro. Just imagine you don't see it. It may be located somewhere else. You can have kind of more hidden logic than this one, but the main idea is that you don't see directly, or it's maybe not as easy as like in previous case when just have the logic here to see what is the actual implementation of this method, which will be called here. So you can usually you can press on Control, and you can see the declaration, which makes sense that the declaration is here. So it will show you not the declaration of the method, like in this case it's here, no, not here, but in that class. For example here, also as an example. But it will go to the declaration of the interface, which is defined as the type. And if you go to the implementation, you can see that you can have the hierarchy, not the hierarchy, but in general you can have the hierarchy of the way of the classes, or maybe even the interfaces which implements this exact interface. So in this case we have two options, but in theory we cannot directly know which interface, which class will be the right one. So in this case we might guess or check the logic, and yes, this is the way we can search for the implementation. Right, and this is why this is called the virtual method, because it has again different implementations. Right, also you can have interface, for example phone, which will extend another interface. So in this case you can have we can extend the interface with another interface. And the phone, have the number of, for example, number of SIM cards, but yeah, not in this case, because that's the interface. You can, what you can do with yeah, you can make a call. You can make a call, and once you have the class, for example, iPhones, you can implement the phone interface, and here you obviously need to implement both methods. So here you can see you have the method which is declared directly in the interface phone, and then you need to implement the method which is defined in the super yeah, it's called super interface of the interface phone, right? The same way as for the superclasses. Yes, that's yeah. Thanks, Svetlana, for the question. Yeah, Svetlana asks in line 20, why do I use extends, not implements? Because said implements we cannot implement interface inside the interface, because the idea of the interfaces, as I said, is that interfaces do not have the implementations of the methods. And that's basically the main answer. That's the answer why we can't use implements, because we cannot implement anything in the interfaces. That's the idea. And yeah, that's the main point of interface, is that interfaces cannot be implemented using interfaces. Interfaces can be implemented in the classes. And even in the abstract classes, maybe let's imagine iPhone, yeah. So let's not use any iPhones here. So yes, even for the abstract classes, abstract class, yeah, let's just Samsung. So, and here you can implement the interface, and again, but yeah, that's the tricky point here. It does not ask you to implement the methods from the interface here, because yeah, that's also point here. So in this case, in this case we have two methods, power on and call. Both of them will be considered as the abstract methods, right? But yeah, by default these methods are considered as abstract, and we can use them in the same way as we use the abstract methods in the abstract classes, in the actual classes which extend the abstract classes, like in this case. But also, yeah, as an option, if you want to do it, you can implement the methods here. It is not prohibited. In case you have such, no, sorry, not call, yeah. Also, you can implement them here without the problem, without any problems. Okay, that's I hope pretty clear for the introduction. And okay, let's move on then. Yeah, about virtual methods again, the idea is that we don't directly know which, and the compiler does not as well, which implementation will be called. That's why we need to check out the logic then. Yes, where the interfaces are used, yeah, if we need to declare methods which need to be implemented in several classes, that was what I said. The interfaces can be used in different classes. So yeah, that's yeah. Another point I maybe missed. Yeah, sorry for this interruption. About if we talk about the multiple inheritance and basically what was the issue, as I mentioned you before. As I mentioned before, why in Java you cannot have the multiple inheritance from the simple classes or from the abstract classes. As I said, the idea is maybe it's just multiple inheritance. Yeah, as I said, the idea, yeah, class. Let's just have some kind of templates. Class m, class bm. Both of them can have yeah, or maybe protected. What would it be? Protected void run. Just again, let's do some stuff, technical stuff here. Yeah, technically do some stuff here. So just for example, print. Yeah, I usually use just system out print on for just because it's the most simple way to just to implement something. Right, but yeah, it doesn't really matter what we implement here. From AM, and the same one can be used for from BM. And the idea why we can't, like in C++, you can extend AM and for example BM. That's incorrect. We cannot extend multiple classes. We cannot do the multiple inheritance. Not in this case. Even in this case, it's not allowed. It's not allowed by the by the idea of Java, because the problem is that there can be two. In theory, there can be two or more same methods in both classes in different implementation. And if we want to, for example, from here, let's create the object. Yeah. So the idea here is that if we want to create the object and we call the method run, in theory it doesn't know if we had two superclasses. In theory, how can it know which method to be called, right? Because we have two methods from two different superclasses, and it does not understand, and it doesn't make sense at all, right? But for the interfaces, it is possible. Let's maybe just redeclare them as interface. Yeah, of course, for interface we cannot have the implementation. The same way here. And we can have the oh yeah, we cannot use protected one. Just use the simple one. And here we can just again change it to implement. Yeah, again, just for those who don't really remember it, just again for abstract for the classes, for the superclass we use extends keyword, for the interfaces we use implements. And again it asks us to do the implementation of the and again here we, despite the fact that we have the same methods defined in two different interfaces, it is not prohibited to implement both of them. Why? Because in this case we don't really care which interface, which method this one or this one is implemented, because they are the same. So once we add the interface, we just add to the same things, and we just use these things. We can redefine them. Run. Now we have no issues because we actually have the method here, and we don't really care if two or more interfaces have the same methods defined. Right? I hope it makes sense for you. Why it is so, and of course we can have we can overwrite them, or not overwrite, overload them. We can overload them, and in this case we have two different methods. Again, same way as for the methods inside, just if we declare them inside the class. In this case, these methods are considered as different one, and even in this case even more, we have no conflicts. And here we can override the same method as well. Yeah, not the same method, but the method with the same name, but with different parameter as well. And that's why we cannot use the multiple inheritance as in the way of classes. We can use it in the way of interfaces. Okay. Yeah. Let's move on. For the second step, we need to expose class behavior without exposing class itself. It's also pretty straightforward. Then one need to generalize behavior of different classes without inherited relations. Yeah. Again, if we have the interface, which is used in different classes, A, B, C, D, or G. Yeah, different classes. So it can be generalized in this way. Also pretty straightforward, I guess. Then when we need to implement the multiple inheritance, again for the implementation of different interfaces. And So let's move on. Then there's so-called robustness principle and interfaces. So yeah, the idea is that you need to be conservative in what you send and be liberal in what you accept. And when implement interfaces, that means that you can accept wider range of types in past parameters than they are declared by interface. Yeah, that's true, and you can return more narrow types or values than declared by interface. That's also true, and you can throw only more concrete exceptions than declared by interface. Maybe, yeah, we'll talk about the exceptions very soon. It's also kind of idea for interfaces. And imagine if there is a piece of cheese, then for example it can have multiple interfaces for defining it. And yeah, as interfaces are public classes, they provide public access to all its methods, and that can a bit violate encapsulation principle, but maybe we'll talk about it a bit later. Right. So this, yeah, another statement. This is not actually really true. So let's maybe cannot be instantiated. Yeah, instantiated. That's maybe a small correction for the slide. Yeah, as abstract classes, yeah, interfaces cannot be instantiated. Again, which makes sense. We cannot instantiate the object without the implemented methods, without the implemented date type, right? It doesn't make sense, and I hope you understand it why. And yeah, using the interface, we can get the working reference to. Yeah, it can be tricky. It can be tricky. Maybe not in the cases I've shown, but if we imagine if you have the classes which are maybe yeah, maybe they are really really hidden. Let's call it like them like this. They are very hidden. They are located somewhere on somewhere very deep from the perspective of the place you are writing the code. Maybe you can maybe you don't have the direct access to the class. It's also possible that some classes are not available for you in in the projects you are working with and with the classes you are working. And in this case, maybe you are just allowed to use the interface, but you don't know about the exact class which implements this interface. Like in this case, for example, you have the method getReference, which maybe can have very complicated logic inside. Then in theory, there can be like 100 and more possible the type of references to be returned. And in this case, you don't actually know which class is located under the reference. So in this case, yes, it may be tricky to understand which class is exactly returned here. And yeah, if, for example, for new frameworks, there can be lots of different tricky places where to where to face this issue. And yeah, have to have a look at Java doc for all implemented classes. That's the documentation for them, and have to check if there is there instantiated of constructor so-called factory method which uses constructor internally. And maybe you can that's again the link to the Wikipedia. We will well, here you can see the factory pattern. Yeah, maybe we'll not talk deeper here. Yeah, not, but maybe, yeah, we choose constructor's turn, but yeah, maybe let's, I think I mentioned to you once about it, but maybe let me just remind you that test factory, so-called factory methods. Let's imagine you have the class, with class, factory class. It just doesn't really matter about what's the name, and we have the constructor which is defined private. Right? I think you remember this case. It's not quite a very usual case, but it's possible. Then yeah, we have the constructor which is defined private, which means that we cannot instantiate the class. We can see the class, of course, because it's defined as the default one. So there's not a problem with this, but we cannot call the constructor here. We cannot call the constructor from here because because this constructor is defined as the private one, right? Hope you remember when we were talking about and in the usual case how to deal. Here is to have a static public static factory class get instance, and here of course you can create the instance. Yeah, of course in this case it's very simple. It's a very simple way. Just imagine we have the such case. Yeah, but if you have maybe more complicated logic, like for example, yeah, like imagine we have another interface here. Interface factory, kind of, yeah. Okay. Yeah, just maybe let's not. Well, we'll talk about there are some interfaces which actually don't have anything inside. It's also a possible case, and this case is also used where actually there are no methods inside the interface. It's also fine. We'll talk. I will mention you. Maybe let's. Yeah, maybe later mention why such interfaces are used without any methods. Yeah, maybe I can tell it now. The idea is that these interfaces are created just to have the not kind of signature, but to point. For example, in this case, we have the factory class. Then we call it implements factory implements factory, we don't need to implement anything. And for example, we have kind of another, like for example, Boeing, right? Boeing factory. Then let's implement factory, implements factory. So everything fine in this case, and basically the idea is that we don't have any anything inside, but we use this interface in the classes, and the idea, just the simple idea, is that we want to point to these classes to distinguish them, that these classes are the factories. Just that factory class is the factory, then Boeing class, Boeing factory is the factory, and for all these cases, just need to point that, put the signature that this class is factory. Also, we can use this way, like not, yeah, maybe let's, for example, here we can find the factory, public static factory. Again, the interface can be used as the type. Here we can also deal with this type. Here it's obviously not correct that we want to pass the superclass to the subclass, because again here we can see that the interface type is returned factory, which is considered as the superclass of the, not as the superclass, but kind of superclass of the class factory. In this case, it's considered as the downcasting, which of course cannot be done without the cast operator. And so in this case, we have kind of a bit tricky logic, that we have the factory method to get the instance, and here we can also kind of have let's just have kind of position, and we can have kind of logic inside case, switch position. Then if we have position 1, then return new Boeing class, for example, right? And if we Boeing factory, and then if we have position case 2, then you don't need break, because we already returned, so we go out of the method. New factory class, for example, we can have such, and by default we just return, for example, we can return nothing by default. Maybe let's make it more clear, than let's case default. So what was the, sorry, it's maybe, sorry, not case default. Just simple default. Just return nothing. So, and here we can see that this problem here. Yeah, we need to add the position we actually want. So in this case it will work, in this case it will break, right? Because, so where's the error here? Yeah, you can see that in this case we'll face the exception because we tried to cast different class to the factory class. So in this case it's Boeing, we turn the Boeing factory. And yes, imagine that we have some such complicated hierarchy. Yeah, not complicated, but more complicated than the simple hierarchy. And yes, that's maybe the idea. That's the idea of the factory classes. So imagine we can have complicated logic for them, and that's why it can be not as easy to just simply create the object. Alright, maybe let's have the 10 minutes break, then we'll move to the final part of our today's session. Okay, let's have the final 20 minutes of the session tonight. So yeah, let's move on with some new features, new properties of the interfaces which are introduced in Java 8. So since Java 8 it is possible to define the method body in the interface, but we need to make it as the default method. So maybe let's move on with the same example defined here. Let's have the class. Let's have the class test interface default. And let's have and then yeah, let's define the interface here. Void draw. Default void message. So we point message here, system again out. Okay. Default method. For example, then we have the class rectangle. Which implements drawable. And it asks us to implement the method draw to draw. So let's implement it and yeah, that problem can go. Let's kind of put it so it's interface. So yes, and here we can print that we are drawing the rectangle. Yeah, and here just need to interface. Draw we can run it and we can see that first of all the drawing method is called and the default method is called. Yes, and let's for example do it this way. Then we create that's rectangle, but let's have the square. Then imagine that we have same from square. Then yeah, for this one we don't really care. And yeah, let's imagine that the class implements both of them. And here we have the problem that it has the conflict. So yeah, basically this is this is this is the way of multiple inheritance, which is implemented in interfaces, and if we do the implementation for the methods, we can have the conflicts. And yeah, that's the problem. We cannot allow these things to happen. That's why be really careful when you use default methods, because that's the problem. In this case, we do not actually know which methods to be considered as the right one. That is basically what I said when I was talking about the multiple inheritance from multiple classes. So yeah, for this case, it does not allow us to act this way. That's why be careful for default words. But for the static voids, it's absolutely fine. Maybe let's not use default here. Let's just use, yeah, let's for example have default void here and static void here. As you can see, we have no conflicts because yeah, as you remember, static methods are not considered as the part of the object. That's why, yeah, but here we still have the conflict, because not the conflict but the problem, because it's not a part of the object, and yeah, again, all the static methods and attributes are the part of the classes, and all the instance methods and attributes are the part of the objects. So in this case, we cannot call the method message from the object T, because it's defined as the drawable, as the interface drawable. And here we don't have the instance method message, but we have the static method, so which can be called from the directly from the interface if we want. Yeah. If we want, we can call the static methods directly from the interfaces. It is all just in this case as the simple static methods. Yeah. Called static message is displayed, for example. Displayed. So in this case, you can see that the static message is called, and so in this case, in interfaces, yeah, for static attributes and methods, it's very simple in all the places, in the abstract classes and simple classes, and in the interfaces you just have the static method, which is the part of the class interface or abstract class, and you can deal with them in the same way in all the areas. Right, so for the static classes, for the static methods, it's pretty simple. It's pretty simple. Yeah, can we declare them as protected? No, we can't, because again, for the interfaces, you cannot. For the static methods, you cannot declare them as protected one, because it doesn't really make sense from the perspective of object-oriented programming. However, we can we cannot declare the simple methods as the private one, because this is the interface. We cannot declare, and yeah, in this case we cannot even implement the method as for the abstract classes, because the idea is that we cannot override them in the classes where the interface is implemented. For the protected, same way, but this is just a feature of the interface that we cannot change the access modifier for them. But for the static methods, yeah, it's simple. We can declare them as private or as public. Maybe let's just write again as protected to just see the message. Here it's written that illegal modifier for the interface method message. Only public, private, abstract, default, static, and strict FP are permitted. Not strict FP. That's a bit different thing, but I'll not talk about it now. So yeah, protected cannot be used, but private and the public one can be used for the static methods. Right, and yeah, this is about the static and default methods. Be careful using them. Okay, let's we'll have 10 minutes. Let's move on a bit. We'll have more examples tomorrow, so don't worry if you miss something. Yes, that's a marker or tagged interface. That is what I taught. I already taught to you today. So imagine if we just have the interface without any implementation. This maybe clonable. Let's maybe again this is class test markers. Okay, let's imagine we have just a simple class. I don't know if I do already have test class or not. Okay, yeah, thanks for I don't have such class. Then we can implement, I think, the clonable. Yeah, you can see that from the Java language there's a default interface. We already used it. It points us that the class is clonable, and let's measure again. Let's some attributes here. Maybe just some public attributes. So it doesn't really matter for us now. So we have the object here. This class object 1 new test class. We want to have, remember, if we pass the one reference to another, so it means that if we change something inside this using this variable, so it means that the value from this variable will be changed as well. Yeah, just a small reminder to you. But the idea, if we clone, maybe let's just keep it as is. If we clone, I think you need also to as I remember, there was we also need to extend moment. There's a class which we need to extend. Oh, okay, yeah, this one no, not here. Is it through a private one? I guess, yeah, one moment, sorry. Just clone. Okay, I think no, but why the method is not yeah, of course we need to combo, then you need to override the method clone here. Oh yeah, it's protected one. It's protected one, so yeah, we can override it to public. And oh yeah, that's why it was not allowed us. Then we can do the casting. We can do the casting to the test class. Yeah, we already did it before, and yeah, the idea is that we need also to throw the exception. Try, maybe here, try. Catch. Yeah, so in this case we'll catch all the exceptions. Catch all the exceptions, yeah, but in this case we just need to catch clone not supported. And what's yeah. Oh yeah, that because yeah, that's we need to define it inside the block. Right, so here we have the interface. We can just check what's the yeah, not sorry, that was not the right but yeah, here. So go to decoration, and here we can see that it's just an interface without any implementation. That's the generic interface by Java. Yeah. So here is just a public interface without any implementation. And again, the idea is that we point to the test class that this class is clonable, so we can clone it. Maybe it should work even in even yeah, in this case we don't have any errors, but it's just if we point that it implements the interface clonable, we just point that this one is this class can be cloned. And then yeah, this is one of the examples of the marker interfaces. Of course, there can be lots of different examples for them. Just also, for example, in this case, yeah, also the way how you can test if maybe not like we're not using this try catch, but if we use different try catch, like in this case, yeah, let's have another try catch, and let's catch maybe, yeah, this we already use it. Cast cast is not supporting. What was the exact cast not supported? Yeah, I just forgot the name for not supported cast. Which cast? Maybe cast expression. And cost exception. Yeah, this one already used. Let's just system out print ln. This is not callable. And for example, if we want to try to, so yeah, this is try catch, which needs to be done by default to do the clone, but here we can do our own check. Yeah, maybe not even here, but yeah, let's have. And here we can have the interface test object, for example, and here we can pass the again we need to do the casting, and in this case what's the problem? Oh yeah, needed and shouldn't be no errors here. Yeah, we don't have any errors. Now we have no exceptions, but imagine if we remove this marker. So, and let's check it now. And now we can that's strange a bit. Why it allows us to object one test class. Okay, this is a bit strange. Why it allowed us to cast? Because actually, okay, maybe not. Maybe do it this way. Let's do it this way. Then let's. Okay. Okay, maybe just let's check one thing. Supported. Oh yeah, yeah, that was, so yeah, we don't really need this one because that's already done using the method call. So actually this method checks if there is the marker class callable here, right? If it is here, so we don't have any issues. Otherwise, exception is caught, and So yeah, that's the idea of the marker interface. And the logic which checks it is implemented here inside. We will not go deeper here. Just the idea is that it raises the exception, call not supported, exception, and we go here. Right, so yeah, that's maybe it for tomorrow or for today. And yeah, just small announcement that we'll have the knowledge check on Monday. So it's just quite small test. With most of the questions are just with true or false. Will be with true or false. So be prepared. On Monday we'll have a small knowledge check during the class. Right, and yeah, now is the time for your questions as usually. Please write the questions if you have. You can ask me the questions as well. Google Meet if you want. Can you see there's Ilse and Svetlana typing something? Yes, Ilse, yeah, the question, do we still have the YouTube stream? Yes, we have the YouTube stream now. And you can watch the recording as well. Yeah, the question from Svetlana, why do we need to use casting in line 12? In line 12, because because you can see that the method called method clone is the method from the class object. Which yeah, you can see that's the class which is used as a superclass for all the classes as the base class, the basement for all the classes, and it has the method clone. Protected, yeah, it's protected one. Protected object. Yeah, but yeah, okay, maybe yeah, this one, protected native method object, which returns type object, and that's what we do here. We have the returning type of object, and as you remember, we need, in this case, it's considered as the downcasting, because the object is more general than any other classes. That's why to pass the reference from the variable object to any other variable, any other class, any other variable which is declared as the class, you need to do the downcasting. That's why we use casting here, because the method clone again returns them. We can also do it maybe in more easy way. Public test class. I think we cannot. Yeah, we cannot. We cannot declare the method with the same name, but in theory we can have clone. Can kind of clone me, for example. In this case, it's not prohibited, and we can do the logic here like test class. Test class clone equals, here we can we can do the casting here. Right, in this case it will be a little bit hidden, but oh yeah, and of course we need to have try catch here, try catch here. Yeah, in this case we won't really need it here. Yeah, and try and catch. So if it's catch, then return nothing, otherwise return maybe you don't really need this one. You can just yep. Yeah, you can just return this way. Call me and yeah. In this case we can just we don't really need to cast it here. So in theory you can just define everything inside the class, and it will be a little bit easier to use it after that. That's also as an option. Right? Yes, any other questions? Okay, then we will have the session tomorrow. We'll have the session tomorrow as usually at 9 o'clock. Mostly, I think, yes, we'll finish some slides from the presentation, and we will also go through some examples related to the abstract classes and interfaces. And I hope tomorrow we'll have a lot of time for your questions about the homeworks, about the exercises. Yeah. So tomorrow you will be welcome to ask the questions. Maybe we can also have, if some of you need, we can also have the call, so we can discuss it maybe more yeah, not more, but just deeper, with more details. Right, then yeah, regarding to the session, I think that's pretty it for today. Thank you for your attendance, and see you tomorrow. Bye.